Thank you. Yes, and I heard from somebody also that I'm the only guy who made it to America to speak here, no? From America to speak here. Or is there somebody else? Not sure, well, yeah, anyway. But that was a very nice of you to put me at what is 5 a.m. my time, so that is absolutely best time to be speaking, so if you find me dozing off in the middle of a sentence, you know that's why. And today we're going to talk about the MySQL and performance optimization and troubleshooting. And what I will do in this talk is I will cover briefly what I think about the approaches you can take to this topic, then brief intro in the PMM and Percona monitor management tool, and spend the most of the time doing demo if internet and other things cooperate. Okay, so first let's look at the performance optimization and troubleshooting from a very high level. Now, as a gentleman mentioned here, I run the company as a CEO, though my background is largely technical. In this regard, you have to deal with this topic from troubleshooting performance optimization from different angles. And you get to understand what if you look at a company, different people think about that in a different way, right, and have a different priorities, right? To sum this up, you can think about, obviously, developers. And the developers, they often think, oh my gosh, why this dumb database cannot just work, right? Especially if you think about developers who do not understand the schema design, indexes, they can say, well, what is wrong here, right? My query is just very short as usually, but it's for some reason runs very slowly. Why it cannot just work? Now, if you are having some business role, let's call it a manager in this case, right? Then you may also be thinking about the costs. You may not want your database cost a lot of money to run. And I think this is especially important in the modern age of a cloud, because modern clouds, they often allow you to scale the instance size by the credit card, right? If a database runs slow, you can just get a bigger instance. And frankly, many cloud providers would want you to do that because that is how they make the most money. What's worse, in the distributed database space, right? You're no more even limited to a limit how you can go, right? You can run extremely inefficient applications and just have an extremely large database deployment, right? Because even a full table scan is very fast if you distribute that over hundreds of nodes, but well, it wouldn't be efficient, of course, right? And then there are also the DBA, or you can think about that database engineer, database reliability engineer, right? There's a lot of titles which correspond to that. You can say, well, you know what? I want my developer happy and my manager happy, but you know what? I also want to get some sleep sometimes, right? Anybody like sleep here? No? So, now, when it comes to the database, how do we use databases? If you really look at the database from a very high level, you just connect to the database and you throw a bunch of queries at it, right? If you remove all that abstraction about the magic happens inside. And from that black box perspective, you really want to make sure what your queries are fast while doing so, right? They report correct result, right? Because that is also important, right? I remember there's like a old joke in the MySQL space, well, which saying, well, you know what? It's very easy to make your MySQL to go fast. You just change the table for all engines to black hole. If you do that, all the queries, insert, update, select, run very fast. But results may be slightly incorrect. right? So you have to be thinking about that. Now, also, especially if you are running the application, where you have many applications running on the same database, you often think about the impact of other applications for the database, right? If your applications run fast, but other users are being starved, that's maybe a problem, right? And here we have, like I know, like a Java programmer is often guilty. Anybody runs Java here? Same question in this talk? No? No, okay, well, so we can blame Java for things it should be blamed for, as well as things it shouldn't be blamed for. But anyway, the thing with Java programmers, if you're writing to the database and it's not fast enough, what do Java programmers do? Well, why don't we now create 100 threads? If it's not enough, 200 threads, which will run the database, right, at the same freaking time. And guess what? When that Java application runs, it's maybe doing that with acceptable performance, but everything else completely stalls, right? Well, you probably don't want to be doing that, unless, of course, you have that database, right, in only being given to you, right? Well, and of course, to keep our manager happy, we also want to make sure of what that is cost-effective. All our workloads needs to be efficient, otherwise it uses too much resources, require us scaling by the credit card to large instance sizes. Now, another interesting thing about the database observability is, where do we get that data about the queries and query performance? Right? One approach, of course, is we can instrument the application itself. And there is a bunch of, frameworks in this case where you can get all the queries your Java application runs, right, or something sent somewhere, right, such as with open telemetry. And that gives you a lot of good information. The problem, though, in this case is what you only get a very high level of information. I ran this query, it took this amount of execution time. A lot of lower level details are only available on the database side. The plan the query did, right? So all the various events happen during that query execution. And because of that, if you really want to resolve complicated cases, you usually want to have a data taken on the database side. If you can take it both from application side and a database together, that's wonderful, but do not just focus on the application side, you will be missing. The next thing I wanted to cover here is also this, right? In many cases, as I mentioned about the developers, like they like to see the database not being the problem, right? But I think in the end, their database executes the queries you supply, and really the volume and the kind of queries, good queries, bad queries, that is application responsibility, right? Often if you write that application, that means your responsibility as developer. And what that means is what really a lot of database problems, they cannot be just solved by the DBA alone, right? I think that is important. We see that in many cases, especially in some, larger enterprises where there may be sort of like this wall between devs and ops, right? DBA is saying, well, you know what? It's for us to solve this problem. Developers tell us, just you guys operate database. You need to figure out how to scale it. We don't have time. We are focused on other product features. Well, that is not really going to work. But anyway, right? So from with that, the focus on the queries, what you have, query volume and a kind of queries, that is a very important way to look at the database performance. From another standpoint, we often like to look at that from a resource focus, because if you think about oversubscribed resources, they are going to impact performance badly. If you have a lot of CPU-intensive queries, for example, and you have a weak CPUs, then all the system will run slowly. And both bad queries, which use a lot of CPU, as well as good queries, right, which don't, they will be slowed down to a certain extent, right, because of CPU contention. Now, when we speak about the resources, when it comes to the database performance, I usually like to look at those 4 primary resources in the database space, where you look at the CPUs, memory, disk, and network performance. In most cases, if issues are resource constrained, then one of those resources would be running quite hot. Now, again, CPU resource use, that also may be the query problem, right? It's maybe you just have queries which require too much CPU and they need to be optimized. But in many cases, that is sort of trade-offs you have to consider, right? In cases if your queries are not like horribly bad, you know, like 1,000 times worse than they should be, but just in a few times bad, then, well, maybe it's easier to invest in a faster CPU, right, than trying to get last few percent, right, optimizing the queries, because, well, the law of diminishing returns, right, tend to apply to query optimization as well. So another interesting thing about the resource utilization is that needs to be looked at sort of like a global scope, right? Where I'm looking at the query execution plans, how many rows it's processed, and so on and so forth. That can be looked at particular query by query. The resource usage is more global. As such, besides this particular query impact and performance, you can see other queries. You can also see the database background activities, right? Like database have to do certain things in the background, which also requires CPU usage, and maybe kind of in a different time intervals when your actually query completes, right? For example, you may be running a query which modified a lot of rows, and then IO activity of flashing that dirty data from a buffer pool to the disk may be well after that query completed, right, as an example. Other processes on the same node may also have a CPU, not CPU, resource consumption, right? For example, in some cases we see people complaining about performance problem which corresponds to their backup jobs, right? When some backup takes a lot of IO activity, which slows things down, which are not even caused by the MySQL process, right, but something else. And also depending on how your virtualization, isolation works, right, with noisy neighbors, that can be another problem, right, when you have on the same physical host many virtual guests, right, which can impact each other. And again, depending on configuration, the system you use, sometimes it's maybe small, but that's or may not be. So when it looks like the approach, if you think about the troubleshooting or performance optimizing your queries, we tend to look at that both from sort of a resource user standpoint, of a query standpoint, right? Kind of depending on the problem and depending again where their low-hanging fruits are and what is easier to do, because timing is also rather important. In certain cases, for example, in the cloud, you may say, hey, you know what? It's like easiest for us to increase the instance right now, right? So we are not down anymore, and then later on spend time on optimizing the queries. On other case, in some of traditional data center environment, we can say, well, you want a bigger box, we have like a 3 months lead time to do that. So there is no freaking way, right? That actually is an interesting standpoint, because with that we find as we get this scaling in the cloud becomes much easier, then the average optimization became much worse, right? Many people just do not optimize the systems just go easy and expensive way of bigger instances. Okay, so I was going to show you a tool called Percona Monitoring Management, but let me explain that what it is first. Anybody here heard about PMM? Okay, few things for a few people, not a lot. So not quite surprised. So what is a PMM? This is really a purpose-built their monitoring and observability platform for databases. I focus on MySQL here because, well, frankly, that is where a lot of my expertise in, but we also support Postgres and MongoDB because there's other database technology which Percona focuses on. This tool is 100% free and open source, right? And that is the tool you roll your own in a cloud or your own data center, laptop, or wherever you want. And it supports both your sort of normal deployments as well as a cloud deployment such as Amazon RDS, Google Cloud SQL, right, wherever for those technologies. And it is called monitoring and management, right? We are building other set of tools right now, right, to deploy, do backups, even database as a service functionality in PMM right now. But in this talk, I will just focus on the monitoring piece. And our goal with PMM, and what we have a lot of our customers and folks in community using that as a tool really to bring together developers and people in operations together so they can have kind of meaningful discussions based on some facts about their database performance, right? Okay, and now it is show time. Let's hope it works. Okay, so you can see it. Yeah, let's see. I can maybe increase it a little bit larger for you. So this is how a PMM home dashboard looks, right? I mean, nothing in particularly sexy here, right? It gives you information about the different deployed nodes and so on. Right. I think what is interesting in this case, what you would find, one is information about the queries. Right. As I mentioned, the queries is something which you will focus a lot of time when it comes to their database performance. Now, if you look at how we run the queries, a lot of them here are ranked by what we call load. Some people also call it like an average active queries. I saw at this open telemetry presentation, I referred something very similar as an impact. But that is basically you can think about that as a number of queries, right, multiplied by frequency. Right, so obviously in this case, right, the queries which are either slower or queries which are very frequent, right, they cause a lot of impact, right, as it's highlighted here, and you can see that on top. Right. Now, with that, you can go and drill down to a particular query where you would see various metrics in this regard, right? And we provide for selected interval right now, like 3 hours, where the time, right, the history of that particular metric. Why is that important? Because we often see database performance problems are caused by some sort of like an outlier in changes. You may have a query which has, certain number of execution a second, then boom, for some reason it goes 10x higher. If that happens, well, that is often can be cause of a problem, right? Or you may find something like the query number of execution actually goes down, but you have a spike of number of rows query processed. Well, as a cause, for example, because query plan changed for some reason and now it uses less efficient plan, so it does a lot of data crunching, but the database is not able to process as many queries a second as possible as it was, right? So that is where we can look at that. Another thing which we see here is a query example and explain. In a database world, right, that is a very powerful tool, right, where you would want to understand, hey, what is going on with this query? Well, you check and explain to see what's going on. Now, often if you are looking at explain on itself, it does not really give you whole information about, hey, what you should do with that. Let's say you explain tells you this query doesn't seem to be using any index. Well, if you don't see the tables, you may not know why, right? Is there an index and it's just not picking it up for whatever optimizing reason, so is there an index missing at all, right? And because of that, we provide information about the table as well as about the index, their kind of cardinality, table size, right, which all may be kind of meaningful to see how you would approach this, this query optimization. Okay, so these are the queries. How the tool also works is if you are running the large environment, you often would have many database instances which are all used by your application, right? And with this ways, we aggregate and capture information for all the database instances, right, where you can sort of drill it in. So in this case, for example, we can look at what a given schema is responsible, right, for vast majority of a load, right? We can also look at the different nodes, their load corresponds to, right? And that is often is very helpful if you want to analyze that. You also can look at the breakdown by the client hosts, which you find very helpful because in certain cases you may find, well, some client host maybe has not some new code with optimization deployed, right? Yes, we should have automation and everything has to be kind of uniform, but you know, world is a messy place and sometimes it doesn't work, right? In this case, you will can be see that very easily, right? If one client behaves somehow different than others, right? Or another thing what we find very helpful, especially with databases which are shared using multiple applications, is if you have the different usernames for different applications, which is a good from even kind of security practice anyway, then you can also see how much load different applications generate and also to focus on that, that particular thing. Now, as I mentioned, if you look at the tool, in this case, you provide information stored by the load first and foremost, and the most basic columns, right, which exist pretty much for any data source, right, like for any database. Query count, query execution time. You can also look at some you know, information about response time distribution here, if you log. And then you can also add a bunch of additional data if you are interested in in optimizing something. Like, for example, we can look at like information about the rows red. Oops, hello. Yeah, which will. No, why did it rows? For some reason, rows red is not showing up. Okay, let me show something else. You see, that's what happens when you do the live demo. And then, okay, yeah. Now we have a information, right, which will give us information, the column about rows read per second, right? So if you can see, hey, I want to look at the rows which are doing a lot of data crunching, then you can either sort by this way, and you can see in this case what the load, the order of the columns changes, right? So it's not the same as it was, right? And then we also can make this column the main column, right? In this case, you will see the sort of histogram history about the rows examined, right? Remember, as I said, sometimes you may have a query which had like spikes from examined because of some plan changes or something else. Now, another thing what I would show here is what, in addition to looking the top queries, we can also look at the top other objects. Like, for example, if you want to understand what application creates load, right, we can pull it out, right, and see how load from different applications is changing, right? And you can see where let's say this rows examined, right, caused by this application was approximately uniform. This one was kind of growing, right, over last 3 hours, right, for whatever reason. Okay. Now I mentioned this case where what you can do the drill down in this case, and you can see. Let me kind of go back to the load metric. We can drill down to the schema. In this case, right now we will be looking only at the TPC schema, and now we can see what if you look at the databases, the TPC C1 schema, most of the load comes from a MySQL 4 database, right? So we again can sort of zero in what is going on, particular queries which are hitting this database, right? In this case, what we can see, especially if you look at our rows examined metrics, what vast majority of rows, right, crunched, is caused by the first query, right? Looking at that query, what we can see here is this. That is, for me, is a very helpful metric to look at for many select queries. How many rows does a query has to crunch through to send one row? And in this case, we can see what it examines 100,000 rows for every row sent. That is a very good indication of a very inefficient query, right? Because generally you expect, you know, maybe few rows, right? Because you have like a joins, you would do that, right? Sometimes you have a group buys, yes, that will be higher, but that's also a good measure of efficiency. If you go back to our query, though, we can notice what this query does not justify this behavior, right? That is pretty much a query which selects data by the key, right? It's pretty much should only examine one row for row, the row sent. If you go to check the explain for this one, you will notice though what this query is doing full table scan. In MySQL, when you have a type all, that means it scans all rows, and it estimates to scan about 100,000 rows, right? Well, not a good idea. And if you now take a look at the tables, you will find what this table for some reason doesn't have a primary key. Well, because I removed it, right? But but in a real environment, you may find what some of the tables, well, have been missing keys for a variety of of reasons, right? Now, I think what is interesting in this case is a lot of problems what we see about that kind of things being non-uniform happens with the automation going bad, right? Like, for example, you may have your database, let's say, migration script saying, well, you know what, I am looking to modify how my index is structured. I will drop a key and then I will add a new key, maybe with a different sequence of columns or something else. Well, guess what, right? If that deployment crashed in that reason for whatever reason, right? Maybe you were restarting database server, maybe something else happened, right? Which can easily happen at scale. If your restart of this process is not robust, then those things may happen, right? And then you may be dealing with kind of surprise schema differences for different sharded schemas or different nodes and so on and so forth. Okay. Any questions so far? Or did I just lose you completely? Oh, yes, yeah. Yeah.
Where does PMM get its data from? How does it interact with the database?
Oh, okay. Where does PMM get the data from? So we have a couple of data sources. Right? You can either use performance schema in MySQL, or you can get data from the slow query log. Right? In slow query log, we also support sampling. If you're using Percona server, then you can say, hey, I want only to sample one of X queries. And also, in addition to sampling, what we can do in slow query log is support the outliers, right? What that means is you can say, well, you know what, if a query is more than, let's say, 1 second in length, I want to log all of those queries, right? Because, well, they are meaningful, right? I mean, it's kind of a funny thing in databases, right? You may have a query which runs fraction of millisecond, it may take an hour to run, right? And while you can sample 1% of those verified queries, you don't want to miss your very bad queries, right? So there's a kind of two data sources. Okay, any other questions so far? Okay, then let me show some more stuff. Okay, so if you look at there, one thing I mentioned, which is many rather common cause of problems, is different processes, right, on the same host. This is something which I think we find particularly helpful in our business, because often somebody comes on and says, well, nothing happens. Why is this MySQL just is acting so slow today, right? And then we didn't do anything, everything is the same, right? And then you look in the node, there may be backup process, maybe some forgotten Java process, or maybe there's somebody hacked the system and it's really running some crypto miner, right, which takes a lot of the CPU, right? With this regard, it's often very helpful to be able to look at the other processes, right, which are running on the box, right, which you can look through PMM as well. And what I like usually is a correlate the data between kind of a global usage, like some CPU usage, and information kind of about the CPU saturation, with also the information about the processes which are using the system, right? And you can see in this case we have, like a MySQL process uses 35% right of single CPU core. The same is very helpful about memory as well, right? Because the databases in particular are very memory-intensive application in many cases, and we often see they are being misconfigured. And if you misconfigure the database to consume, well, too little memory, it can be very bad from performance standpoint, right? Because you're not going to be caching as much data as you should. If you over-provision memory, though, one of two things can happen, right? Either you will have, out-of-memory killer waking up and killing the database, and it kind of crashes and recovers. Not a good thing, right? You will have like periodic database downtime, as you see it from your application, or you may have swapping happening, right, which will impact the database performance severely, right? And that is something what we can look in this case, right? I like looking at the memory utilization, which is your RAM, as well as virtual memory. That pretty much includes your physical memory plus swap, because if you run out of a virtual memory, that is where the out-of-memory crashes will happen, right? And then from a swap standpoint, I do not mind if some of the swap space is being used. Actually, sometimes you have some, junk in the applications which better be kind of put to swap, and memory kind of used for more productive case. But you want to make sure there is not a big swap IO going on, right? Like that's why I think a swapping activity is much better, I think, right? And in this case, you can look at resident memory, right? And then another concept is the used memory. What we look here is the resident memory plus swap space, which is often very, very helpful to understand how much memory given process is actually using. Because if you just use the resident space, well, you don't know, right? I mean, if that's if process use a certain amount of memory, maybe it's because a large portion of that is swapped out. Another process is I've seen people looking at virtual memory. But virtual memory, especially in those days, is not a very good measure. Like some programming language or frameworks, like for example Golang, it likes allocate huge amount of virtual memory, right, which is not never gets committed, right? So it's not a very meaningful measure in a lot of cases as we used to use memory. So in this case, another thing what we can look at when we speak about the swap usage is what is exactly lives in a swap file. And we can see in this case actually the pretty large portion of the swap space we use is used by MySQL D process, right? You wouldn't really expect that to happen. In this case, I would imagine there is, because it's like a very small demo box, there is some, it's actually meaningful because performance schema may allocate pretty large tables due to operation, right? And not really use them a lot. So that is why we see MySQL in a swap space. Well, anyway, that is something what process information which I find very useful in many cases. Another thing interesting insight which you can get also relates to memory is where memory is used in the MySQL itself. Because often you may be puzzled to say, well, I have this MySQL, and for some reason it takes huge amount of memory. What exactly is taking that memory, right? If you need to put it on a diet, for example, to avoid this web file. Now, of course, you can look at your settings, and you can say, well, I have like, if MySQL is taking 200 gigabytes and my buffer pool size, like a cache size, is 180 gigabytes, well, guess what, right? You find it, right? But in some cases, you will find, wow, my buffer pool size is only 50 gigabytes, and the process takes 200. Why is that? That is when it becomes much more interesting, right? And I wouldn't say that's very often happens, right? But it can. And that is where you can look at the instrumentation in a MySQL performance schema, which, as you can see, tells us what are the top users of memory. And in this case, we look at both a global memory as well as memory which is used by different different hosts, right? And we can see actually this kind of interesting example, right? For some of the hosts, is for some reason kind of gradually has growth, right, of a memory allocated to that, or we can use by the user account. In many cases, actually, that is relevant because a certain amount of memory will be allocated per thread, right? So the more active threads you get, right, for a given user, something the more memory they can allocate. Yeah. Okay. Any questions on that? No? Okay. Okay, so let's move to the next thing, which is the custom dashboard. Now, I want to highlight one of the things which I think about the very powerful thing about PMM is it is built on Grafana as a dashboarding engine, and that means what you can really customize a lot of dashboards what you have, right, for your own purpose, or create your own dashboards. In many cases, we see people just saying, hey, you know what, I will copy paste different already made panels from the different places PMM to create my own thing because, well, that's the most relevant, convenient, and so on and so forth, right? And this is the dashboard which was designed specifically for their query troubleshooting. So as I mentioned early on, if you think about the performance, right, one of the approaches you can think about resources, right? But how do we correlate resources and the queries? If I can say, well, my CPU is kind of running hot, what queries may be responsible for that CPU, right? Or hey, I'm looking at seeing a lot of disk I/O. What queries may be responsible for that, right? And this is a dashboard which really looks at helping to answer that question. So if you look at their CPU analysis standpoint, right, we look at both high-level CPU usage statistics as well as their CPU-intensive queries, right? And in this case, we can see, well, you remember that query which we said does a full table scan, right? Because of no index, well, it actually scores highest in our estimates about the queries which score a lot of queries, right? Now, what I think is the most interesting here is not even that, particular case. But what we can edit with this dashboard, and you can see we are using relatively simple SQL query, which does some math for the scoring, right, to compute that CPU score. So that means if in your case you can say, hey, there is, let's say, some other way I want to score kind of my bad queries, what I don't like about them, you can pretty easily create some custom rules for you, right? Addition to what PMM provides. Right. So the same applies to the disk I/O, right? When we can see the queries which show substantial amount of disk I/O, as well as to look at what particular disk I/O is going on at your system. And here, one thing I'm also doing with this dashboard is to bring in together sort of your data from a host, as well as the data we have on the database level, right? Because, so in this case, I can see, for example, a disk bandwidth and InnoDB data bandwidth, right? They correlate relatively well, though you will find what in terms of the data rights, there is a lot more going on a host level than on the InnoDB level in MySQL. Any guesses why? No? Well, obviously because you also have a log I/O, right? In addition to the data goes, as well as MySQL usually produce binary logs, right, which also write on a host file system, or temporary tables may also produce writes, right? So there is some additional writes going on, right? But that gives us their information, right? Another thing what I would want to highlight here is this, right? So one thing which is interesting about the different resources, right, is what all resources, they typically have certain concurrency and which level the utilization is optimal. So let me clarify that, right? If you have CPU with, let's say, 4 CPU cores, right? Let me just forget threads, right? Obviously, in this case, you'll need 4 processes, right, or 4 threads running to consume that CPU. If you will only have a 4 CPU cores, then you will have just 1 thread running. Well, 1 core will run hot, the other will be idle, and you would not really use all resources efficiently, right? Now, obviously, if you have more runnable resources, when you have available resources, then the queuing will happen. And that is, I think, very interesting thing when it comes to the CPU usage. Because if I have let's say 4 CPU cores and my CPU is 100% saturated, there is a huge difference between having, let's say, another 100 runnable CPUs, right, or just 1, in terms of how much slower compared to a resource unconstrained system the workload could possibly run. Does that make sense? So in a CPU case, we can look at the CPU usage relatively easily, and we can also look at what we see as CPU saturation, which is pretty much number of runnable processes divided by number of available CPU cores, right? Which gives us to how much oversubscribed system is from CPU standpoint. So if CPU, it is very easy, but now when it comes to the disk I/O, it is much more complicated. Because I/O systems are so complicated, we do not really know how many sort of resources are serving us. When I had a single spinning disks, it was simple, right? Because a single disk can serve 1 request at the same time, right? The more concurrency you have per disk, well, the more queuing is going to happen. If I have 4 disks in my RAID controller, guess what? It can handle 4 requests in parallel at most, right, if we're lucky enough. Now, if you're dealing with SSDs, for example, those are complicated beasts, right? You don't really kind of know how much concurrency it can handle and at what conditions. If we are looking at the cloud and network-attached storage, guess what? The same thing, right? You do not really know how many physical resources your EBS volume is provisioned on, and also it actually may change over time, right? So with that, what I find very helpful is looking at the disk I/O latency, compare that to the longer-term average. Because what happened here is if you are oversubscribing your disk I/O subsystem, whatever it is, your local SSD or your EBS, right? If you're oversubscribing, as the latency for queuing happen, and the average latency will go higher, right? No. Okay. Yeah. And that is what this graph shows in this case. And you can see, well, there are kind of some spikes here and there, right? But it's generally, you can see where it's kind of, both for reads and writes, it is close to the long-term average. Another thing I think which is very helpful those days is also if you're looking at the disk latency, make sure you separate read latency and write latency, because typically it's so different. In this case, you can see the average read latency and average write latency averages is the difference is 3x, right? In some cases, maybe like 10x, right? And kind of just getting that together is not very helpful. And final thing, as we are talking about the disk I/O, which is interesting, is also this operation of Fsync, right? When a database pushes the data, say, hey, I want to make sure that is pushed through operating system cache, some sort of, like a storage cache, if any, and persistent on the storage. The thing about the Fsync in a kind of in a modern case, it can be rather expensive operation compared to writes in many environments. Or sometimes, actually, it is not, right? Some enterprise-grade system, if you will, right, they may handle that very well. In any case, understanding what the Fsync is a different operation compared to just, normal write is pretty important, because sometimes the spike of number of Fsyncs may be very important for the database performance. Okay. I think I have another 5 minutes, so you have any questions, folks? Yes, okay.
PMM also look at the settings of MySQL or make suggestions about settings?
So that is a good question. So you can look at the settings, and some of them are actually I didn't talk about them, but some of them are displayed in different places, like buffer pool size, certain others. Now we are working right now on the sort of advisors infrastructure, which are in a tech preview, which will offer suggestions, right, about the settings and some other things as well. Okay, any other questions? Yes. Oh, look at that. You're warming up, guys. Oh, yes, okay. Well, that is a good question. So nothing is free, right? Of course, right? So obviously, if you want to capture the data, then there is overhead. Normally, we look at that to capture the metrics data, query data, right? To keep the overhead within a couple of %, right? And typically, that's what it's possible to achieve. We also have a lot of settings in PMM in terms of how to control that, right? You often can trade the data kind of fidelity, right? How accurate you get it, and overhead, right? To find what particularly works in your environment. Yeah, I think. Do you have a question?
So I wonder, how does this actually work? Do you have some kind of agent on the system to collect all the metrics?
That's right. That's right. So there are actually two ways you deploy PMM. So one, and that's what we prefer, right, is running the agent locally, right, which can, process data. It also can capture all those kind of operating system metrics, right? Now you can also run it in agentless way, right? When you can say, hey, I just talk to the database to get the performance from it. But in this case, you may not have all the same level of operating system stats, right? We have like some integration with CloudWatch for AWS, for example, to get some of the metrics, but typically you do not get the same level as you can get from your, Linux system, right? You have access to it.
Another question, what's the database backend for the Grafana?
So for Grafana, we use two things now. Like one, for metrics, we use Victoria metrics, which is Prometheus compatible storage, right? And it talks Prometheus language, but we found that more performance efficient, right? And it also has some additional features, right, which we find handy. And for query data, we use ClickHouse. We also store metadata in Postgres, right? But that's kind of a very small database. Yes, the gentleman in the back. Uh-huh. Well, yes, you can use the sidecar in Kubernetes, right? And also for MySQL, PostgreSQL, MongoDB, we have Percona operators for those database technologies which integrate with PMM out of the box. Yeah, I mean, of course. Okay. Oh, yes. Sorry, I was looking for, yeah. Well, if you think about the, so in your case, yes, I mean, you can have a PMM data sources, right, which you used, exposed, and use the dashboards on your centralized Grafana if you want to. Okay. Anything else? Any other questions? Well, with that minute left, I almost forgot. I also have some swag to give away you folks, so I will just put some on the front of. We have some wonderful. What is it? What is it? Yeah, that's wonderful. Yeah. Yes, it's empty. Yeah, we can. Yeah, and you have, I think there's like one gentleman who was asked so many questions, he wanted to get like some very special present.
Thank you very much.
Okay.
So if there are no questions, then there's nothing left to do but give you some snacks.
Oh, okay. Oh, you also have something for me. Oh, that's wonderful.
Every speaker gets something, of course.
You look at that. But I will get fat. Oh, yes, for kids. Yeah, thank you. Thank you. That's wonderful.
So please give it up once more for Peter Zaitsev.